Welcome everyone. So in this video, I'm going to be demonstrating how you can solder those header pins onto the router UART connection in order to not have to use that twist tie method, which is going to produce a much more reliable connection if you do choose to solder it. And it's entirely optional if you choose to do that. Again, you can just use the twist tie method that I showed before. So if you're already familiar with soldering and you just want to skip to the part where I actually am soldering the header pins on, then feel free to skip ahead. But I am going to start this lesson with just showing the basics of soldering and how we can do through-hole soldering in case this is your first time doing any soldering. So if you do want to follow along here, at a minimum, you're going to need a soldering iron. So I've got mine right here, soldering station, and then some solder. You're also going to need a few items for safety. So the first one is, and I'll show right here, I've got these on. So I always wear safety glasses when I'm soldering. And I know that may sound silly to some people, but if you have worked with solder, you'll notice that sometimes the way that it drops and splashes, it can be very erratic in how it splashes. And the last thing you want to do when you're looking up close at something to make sure you're getting the solder right is have a piece of hot metal drop into your eye. So also generally when you're soldering, you're going to want to have something to remove away the fumes so you're not directly breathing them in. Most solder, including the one that I'm using, it has lead in it, so really nasty stuff to breathe in. So I don't have my fume remover on right now actually, just because I'm only going to make a couple of solders and the sound of it really does mess up the recording quality of the sound, but something to keep in mind that you should also be running that. And then just a couple of other quick safety things. Honestly, this goes without saying, but to be honest, I'll raise my hand and say that I've burned myself with a soldering iron before. These things get extremely hot. We're going to be, essentially melting metal with it, so they get very, very hot. And, any part of them that is metal gets hot. So even though it's just the very tip of it here, all this area, the cage, all of that gets super hot and you could burn yourself on it. So, you don't want to be like this meme lady that I'm going to pop up on the screen right here. And then finally, something to keep in mind is that whatever we are, soldering to, we're going to be touching and heating up as well, and it's going to get hot. So I've got a couple resistors here that I'm just going to be using as test pieces to demonstrate the soldering. And when we're soldering it, like even if we're soldering this end and then we're trying to hold it in place on this other end, well, the whole thing is going to get very hot. And I've personally done this myself before where I'm just trying to really quickly hold a piece in and not use a third hand or something else like that. And you can burn yourself because the whole actual piece of metal is going to get hot. Again, it's designed to conduct electricity, these wires, so they're also going to be very good conductors of heat. So something to keep in mind. Those couple of safety things out of the way, let's get started on our actual soldering. So what I'm going to do is I've got a piece of proto board here that I've broken off, and I just was using this to practice soldering. So the way these work is I've got a whole one here. I just didn't want to waste a whole one for this practice. Is they're kind of like a PCB in that they have all these pads on the back like you would see in through-hole components on a PCB. And then, there's just nothing on this end. There's the drill holes. And these are designed for prototyping when we're making a circuit that we want to be more permanent, but we don't want to actually design a PCB. So we can just put our through-hole components in here, solder them onto the back, and then it's up to us to create jumpers instead of having the traces like we would on a lead. And, another use for these is they're great to practice soldering if you want to get a practice in without actually doing it on an actual board where you might cause some damage to anything. Okay, so I've got mine here, and you don't necessarily have to use a third hand, but it's going to make your life a lot easier if you have one for soldering. So I'm just going to mount this actually in the third hand here. These two. And the nice thing with these 4-1s is we can actually use these other hands then to hold components in if we need. And I've got my resistor here. You can see I've actually been practicing with just a few other before I turn on the camera just to make sure my soldering iron was hot enough. And what you can do with these resistors, if you are soldering any through-hole components like these resistors, is we just bend the leads up. And I'll just pick a couple holes here to slot this through. It doesn't really matter since we're not, actually putting this resistor anywhere. And then with these leads, what we can do is we can just fold them down to hold the resistor in place. So it's kind of nice with resistors and other through-hole components when they have these leads. We don't have to worry about holding them in place. We can get this to hold it down. So I'm going to grab some solder here and demonstrate how we actually make these solder connections. So the first thing you want to do just to check and make sure your soldering iron is hot is we're going to do what's called tinning the tip. And what that is I'm just going to touch a little bit of the solder to the tip of the soldering iron and make sure it melts and we get a good connection here. So perfect. It just immediately melts and I keep a little bit of that on the tip. Now, when we make these solder connections, what you want to do is we actually want to heat up the pad and the component lead and then touch the solder to those and have the solder melt, as opposed to, trying to just touch the soldering iron, get the solder to melt and have that, then try and glob onto the leads. So I think it's easiest if I just show that for the first time. So what I'm going to do is I'm going to hold the soldering iron up to the pad here and let it get hot and let the lead get hot. And then I'm going to touch the solder to that area and pull it away. And perfect, we get a nice solder joint there. And I'll just show it on the other one. Again, I'm just touching the solder to the pad and the resistor lead. And then I'm touching the solder to that pad and resistor lead. I'm not necessarily touching it to the soldering iron tip itself. You see here we get two nice solder joints. Okay, so I just moved the prototyping board a little bit closer to the camera so it's really clear what I'm doing. And I've got another resistor here. And what you can do with these through-hole components, if I just show it in front of the camera, is that we could bend over the leads like this and then just slide them into the hole. So that's how we solder those in. And I'm just going to pick a couple holes at the top here and we'll just slot this through. It really doesn't matter because we're just practicing what ones we do. Okay, we'll do this one on an angle here. So I got the top one here and then over here. I'm just going to pick up my soldering iron here. So the first thing that you'll want to do when you're making a solder is what's called tinning the tip. And this is a good way also to test that our soldering iron is hot enough. So I'm just going to do a really quick tap of the solder to the end and make sure that it actually melts on there, which it did. So that shows us that it's hot enough. And then what we want to do when we're making these solder connections is we don't actually want to be, melting the solder with the soldering iron so it's liquid and then kind of trying to touch that or attach that to these leads. What you actually want to be doing is we want to touch the lead and the pad that we want to solder with the soldering iron and let it get hot. And then we touch the solder to that pad. And you see here we've got, a really good solder joint by doing that, because the way that the solder works is it's actually going to want to flow towards the heat. So what that does is it makes the solder pull nicely around the pad and the component, and it doesn't go anywhere that we don't want it to do. So I'll do another one here, right here. Again, you can see I'm actually just touching the lead and the pad, and then I'm going to come in from the side here and do a really quick solder like that, and we get a nice solder joint. So I've got a couple examples of bad solder joints on here for when I was testing, and just to show you how those happen. So, for example here, this is what happened when I was just playing around with dropping the solder on. So you'll actually get what's called a bridged connection. So we've got this chunk of solder that goes across two, and we've done that here. So I just show you here quickly, how we can get that. If I use these components right here, and I'm just like kind of melting the solder and trying to put it on. See here that it does not, honestly, it's not sticking very well. I'm getting like these globs, and that's what gives us the bridge and a bad connection. So again, that's why we just want to be touching the soldering iron to the pad or the lead and then the solder to that, and that's what lets us get that really nice connection for the through-hole solderers. So if this is your first time soldering, I would really highly recommend getting a couple of these and actually soldering them. So what I'm going to do now is I'm actually just going to do a practice as well with the header. I've got a spare header pin here, and we'll just pick a spot here and slot it in. So you see I'm making use of the third hand for this because there's actually no really good way for me to hold this in place with my hand and then solder it. If you can see it, it's right at the top here, these connections. So I'll just demonstrate a few good solders in how to do those. So the one other thing I will just quickly mention with soldering is you will have noticed there that I didn't linger when I'm making these solder joints. As soon as I notice that it's melted and I've got the solder in the spot where I want it to be, then I'm actually pulling it away. And the reason for that is when we're soldering, some components, especially like transistors, diodes, and integrated circuits, the extra heat from the solder gun, it can actually cause them to burn out. So we want to be, as quick as we can while still getting that good solder joint. So now that we've got a little bit of practice in on that proto board, I'm just going to grab the PCB for the router here, get it set up in the third hand, and then we'll take a look at soldering the header into the router PCB. Okay, so I've got the router installed into the third hand here, and I've got it really zoomed in so I can show you how I'm going to make those solder connections. These 4 pads right here, and this is the underside of the PCB. You'll notice that there's no components or silk screening. This is the underside of that UART header. So what I'm going to do is I'm just going to stick the header pin into there, and I'm going to make use of the third hand tool as well to hold it in place here. So I've just got it snapped in place there with the third hand tool. You can see the leads are coming through here. And if you don't have a third hand tool, what you can actually do is you can hold it in place with a little bit of tape or even some sticky tack or something like that so that you don't have to be holding it with your hand. So same as before, I'm just going to test and make sure my soldering iron is hot. Best to do this actually not over the board like I was just about to there. So I'm just going to check it, but I'm going to check it out of camera here. All right, mine is hot enough, so I'm ready to actually get soldering. Again, we're just going to be touching the soldering iron to the pad and the lead, and then the solder to those. We get a nice clean solder, and I'm going to move on to the next one. Nice clean solder, moving on to the next one. Perfect, and those look good to me. So what you'll want to check when you are, visually inspecting these is to make sure you don't have any bridges. So you can see I can actually fit my pointer here through, and I don't have any solder that's touching, because if we do actually get solder that's going across here, what that's called is a bridge, and then we're going to have connectivity between the 2 points, and that's not good. That being said, what I am going to do now is I'm going to, move the soldering iron out of the way, turn this off, and we're going to do the same thing that we checked when we were using the twist tie method, and we're going to check to make sure all of our connections are still good. We've got that ground connection and the voltages as we expect them. Okay, so I've got my multimeter here, and then same as before, we're going to start by using the continuity setting to do a continuity check between the ground pin and this ground plate down here. And I get a beep immediately, so that's perfect. It means we have a good solder joint and we have a good connection. And I'm just going to check the voltages on the VCC and the transmit pin as well. So plug your router in if you're following along at home. I'm going to switch my multimeter over to the DC voltage setting again at 20 volts. And then the same as we have previously, I'm going to start with the VCC, which is the top pin here, and probe from the VCC to the ground here. All right, and I immediately get that 3.3 volts, so that's as expected. And I'm going to check the TX pin here in the same fashion. And we see it at 3.3 volts as well. So that's perfect. If you want, you can check the RX pin. Should be 0 volts. Okay, perfect. 0 volts, just to make sure there's no bridging or anything like that. And perfect, it's at 0 volts. So we know that all of our solder connections are good, and we are good to go. So if you did take the soldering route, and this is your first time soldering, and it all worked out like this, then congratulations and good on you. That wraps up this video. I'll see you over in the next one.